Hi everybody, this is Buckwheat from the Little Rascals, and we're going to do a lesson on sample proportions. Let's do board problem 44. Okay, if a population has standard deviation sigma, that's lowercase sigma, Greek letter, then the standard deviation of the mean of 100 randomly selected items from this population is, I don't think you've been told this formula yet, it's this sigma divided by the square root of your n. So it's going to be the sigma divided by the square root of the 100, so I get choice C. The square root of 100 is 10. All right, you'll see that formula in a couple of lessons from now. If not the next one, then the next one, okay? All right, so here's 9.2-1, sampling proportions, and let's begin. Section A, an SRS of size n from a large population with proportion P, and if you let P hat equal the sample proportion, then the mean of your sample mean, that's what this says right here, that's the mean of P hat. So the sample mean of the sample is equal to the proportion. It's equal to the large population proportion. Okay, so your sample mean is going to end up equaling your sample proportion. All right, that'll make sense in a little bit. And then your standard deviation of your population, this is my standard deviation of my population right here, it equals the square root of your proportion times 1 minus your proportion to, all over the sample size right there. Okay, let's see, and it's just formulas. You get the formulas on the AP test, and you get them on the inside of your class, so don't worry about it, you guys. The sample proportion P hat is an unbiased estimator of the sample proportion P. And as n increases, your standard deviation decreases, okay? So sigma decreases, and that makes sense, you guys. The more people we get, the less variability that you'll get. All right, I hope that makes sense. And then your sigma formula, your standard deviation formula, it won't work for the sample that is a large part of the population. I know it seems like it would, but it doesn't work if your sample size is a large part of the population. So only use samples when the population is much larger than your sample size. Okay, a large sample is a good thing to do, but it can't be a big part of the population. All right, rule of thumb, use your sigma formula only when the population is at least 10 times as large as the sample. Okay, and we can use the normal approximation, which is our z-score. We're going to go all back to that z-score that we learned back in chapter 2. IFF means if and only if, so if and only if your sample size times the proportion is greater than or equal to 10, and your sample size times the complement of your proportion, 1 minus proportion, is also greater than or equal to 10. Okay, then we can use our z-score stuff. All right, so here we go. Here's an example. Applying to college, and we're going to read the first paragraph, an example 9.7 on page 507. All right, a polling organization asks an SRS of 1,500 first-year college students whether they applied for admission to any other college. In fact, 35% of all first-year students applied to college besides the one they are attending. What is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this true value? Okay, and what does that mean? I bet a lot of you guys are thinking. Okay, we're going to focus on this question right here. We're going to come back to this. What is the probability that the random sample of this 1,500 students will give a result within 2 percentage points? Okay, well, within 2 percentage points of 35%, you guys, is going to be 33% to 37%. You guys get that part, right? We're going to calculate the probability. We're going to do all that z-score stuff in just a second, but we got to calculate the standard deviation. Okay, so the first rule of thumb is your population must be at least 10 times the sample size. Well, okay, well, if we only did 1,500 students, there's way more than 10 times 1,500 first-year college students. In fact, there's a 1.7 million, and this was back in 2000, you guys, so there's probably more now, or, you know, there's more than that. We at least know there's more than that. And the second rule of thumb is that NP is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. Well, N is 1,500, P is 35.35, well, and then this is going to be 0.65 right here, 1 minus that, 1,500 times both that. So those are both greater than or equal to 10, so we'll go ahead and proceed. Okay, so we're going to go ahead and calculate the standard deviation. There's our formula for the standard deviation. 0.35 goes right here, 0.65, because 1 minus 0.35 goes right here, and 1,500 goes right here. Okay, we're going to crank that out. I've already done that for you, so it's 0.0123. So that's our standard deviation. Okay, So here's that question again. What is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this true population? Okay? Or in other words, it's in between, since it's 35%, then 2 percentage points down is 33%, and then 37% down, 2 points up. Okay, remember this formula, z equals x minus the mu divided by the standard deviation. Okay, we're going to go ahead and do that, except my x's are these numbers. These are the numbers that we talk about. We're going to plug in 33 and 37. And we know the mu is 35, and the standard deviation is that little rascal right up here, the 0.0123. All right, now it's just number crunching, you guys. Okay, so we get, when we plug in those values, we get negative 1.63 and positive 1.63. Well, we want to know what's in between. So here's that picture of in between. That's just the calculations I just did right there. So we want this picture between negative 1.63 and positive 1.63. Well, remember, your textbook gives you always to the left. So here's the textbook to the left on this side. That's this little tail over here. All right, so to get this little tail, I just double it to get that right here. You know the whole thing is 1, so it's going to be 1 minus this side and this side right here, or actually 1 minus 2 of that. Okay, so I get 0.8968, so almost 90%. So here we are answering the question, and we need to learn how to answer it correctly. And this is it right here. Almost 90% of all the samples will give a result within 2 percentage points of the true population, okay? And I should say of all the samples of size 1,500. That's what should go in right here. Almost 90% of the samples of size 1,500 will give a result that's within 2 percentage points of the true population, okay? And then just a little note, a reminder, this P with right here with the 33, it just stands for the probability that our sample population will lie between this 33% and 37%, and this is my probability right here. This is my sample probability. Okay, now just be careful when they're asking for probability answers or proportion answers. We want decimal answers. If they ask for percents, then we want percent answers. I forgot what they asked for on this, but you guys get the idea.